The stage is yours.
Thanks a lot. So, hi everyone, good afternoon. Also from my side, my name is Maarten Mulders. I work in the Netherlands with InfoSupport, which is a Dutch IT firm. We do consulting, among other things. And what pretty much unites us is the fascination that we have for amazing technology. And today I want to discuss a particular piece of amazing technology or awesome source technology, as we sometimes call it internally, React. We have only 40 minutes, so that's going to be a bit of a challenge to discuss everything there is to say about React. If you might have any questions, could you please keep them until the end? We will have a short Q&A then. And with that out of the way, let's get started. So what is React actually? React is a library that you can use to declaratively build a user interface using JavaScript and, if you wish, XML. So let's focus on the two highlighted words here. Declaratively, that means React lets you focus on what you want to have rather than how it needs to be built. And we will see in the coming 40 minutes what that means in practice. And the second thing that I highlighted here is user interfaces. React is very well known as a framework for building web applications, but you can build other user interfaces as well. Famous spin-offs are React Native, for instance, Proton. Um, there's even a PDF generation library that builds on top of the ideas of React. You could say that a PDF file is a one-directional user interface. It only allows output, no input. But that's a bit of a joke. We will focus on web applications today, but know that the concepts that we will be discussing today are also applicable to other types of user interfaces. So what sets React apart from other user interface libraries? The first thing is that there's no two-way data binding. You may be familiar with frameworks like Angular or Vue. They offer you two-way data binding. You change something in the runtime of your application, so the code changes a particular variable, the user interface gets updated. You update the user interface, the memory value gets updated. This is not the case in React. If you update something in the memory of your program, of your web application, the user interface will be updated automatically. That's called the re-rendering process. But if you want to react to what is happening in that user interface, you need to bind that yourself. It's not going to happen automatically. Second thing is that React does not have a custom templating language. You may think that the JSX that we will see in a few minutes is some kind of a templating language, but it is in fact not. It's XML. React provides you with the mechanism to build a user interface, and it focuses on that. It doesn't offer you any other things. There's no routing between pages in single page web apps. There's no HTTP client. There's no everything else that you want to have than a user interface is something that you have to bring yourself, which is also different from, for instance, the first version of Angular. That was a complete package, a complete toolkit that basically gave you everything. React lets you write your application in plain JavaScript. I've hardly seen anybody do that. Most people prefer to at least have JSX added as well because it makes the code a lot more compact and a lot more easy to understand. And for larger applications and code bases, I really recommend adding TypeScript to the mix because it will really help you out finding your way in a bigger code base. And finally, React works on a virtual DOM before actually starting to manipulate the actual DOM. And that's one of the things that makes it really different because that really gives a lot of performance benefits. So with that out of the way as well, I want to do a quick reminder of modern JavaScript. I'm not going to cover all of JavaScript. That wouldn't even fit in 4 hours, I'm afraid. But we are going to cover a few things that are added recently to JavaScript and that are used a lot in combination with React. The first thing I want to discuss with you is classes. Here we see an example of a class. If you come from a Java background or a C# background, this may look pretty familiar. This code snippet declares a class, which has a constructor and one method. The funny thing about this code snippet is that I can edit it and that it will be run automatically. So I'm going to say my amount class has 2 parameters in the constructor, and I can invoke the getCurrency method on it. And as you can see, the output below gets updated automatically, but that's not what I want to highlight. What I want to highlight is that we have classes in JavaScript. Classes can have instance fields, currency and value in this case, and can have methods. Second thing in JavaScript is that we have functions. Well, that's something we had for a very long amount of time, and it should be no surprise that if you invoke the isEven method with free, it will return false. What you see a lot in React code bases is the use of arrow functions. In this case, the function keyword is gone, and the function is declared as being a collection of parameters, 1 in this case, a fat arrow, and then between curly braces, we see the implementation of that function. And obviously, this does the same thing. So if I invoke it with free, it still outputs false. And you can make it even a bit more compact by removing the curly braces. This is something that you typically only do for very short functions that consist of 1 line pretty much, because otherwise it doesn't become readable anymore. Very powerful feature, as we will see in a few minutes, is object decomposition. Object decomposition lets you basically decompose an object into local variables based on the names of the properties of that object. So we have an object here, which is a person. The person has a name, an age, and an occupancy. And I can decompose that by saying, give me the name and the age, put those between curly braces, and assign that to a local variable. So now I have a local variable name. As you can see, it gets read from the object. I have a local variable called age, but I do not have an occupancy because I did not decompose that. I did not pull that out of the object. Same works for arrays. I can declare an array. I can pull out some elements of that array and say, well, hey, here's the first element of the array. Here's the second element of the array. The third one is not there as I did not decompose that. I could, of course, do that, and then it gives the expected output. The other way around is also possible. Rather than pulling apart an object into separate properties or variables, I can combine local variables into an object. I have 2 local variables, name and age, and by putting them between curly braces, I compose an object out of that. Let's see what that object looks like by stringifying it using JSON, person as a parameter. And now you see that you have an object with a name with a particular value and an age with the value of 42. Another powerful feature which is, as far as I know, present in C#, I don't think it's in it, I'm pretty sure it's not in Java at least, is string interpolation. Really lovely thing to use, which lets you quickly compose a string using variables you already have at hand. So in this case, I can, well, basically format that string as I see fit, including a local variable without having to do the string concatenation myself. So that's for JavaScript. Now you know all that you need to know to get started with React. These are the type of constructs that you see quite often. So let's dive into this magical thing that I already quickly mentioned, which is JSX. What is JSX? JSX is an extension to JavaScript, which makes the syntax more powerful because it lets you write XML. And if I say XML, I mean XML. So not a string of characters, but really an XML literal value. And just as XML does, JSX allows you to use embedded expressions, attributes, and whatnot. You can nest it if you wish. Now, if you are concerned with security, you might say, hey, but what if somebody tries to inject an alert tag, a script tag, or maybe some formatting? Well, there's automatic XSS prevention available in React. And you can turn that off, by the way, but the way to do that is something that I still need to look up because the the notation for that is a bit obscure. And I think they did that on purpose. There's no way that you're going to do that by accident. If you really want to disable it, you need to look it up. So only then you're sure that you want to do it. But well, the hard thing with JSX is it's a syntax extension, but the JavaScript engine that powers your browser probably doesn't know about it. And that's why we need to transpile JSX into JavaScript code. Transpiling is basically transformation or compiling, just as you see fit. It's none of the above, and also it's a bit of both. So that's why they combined the two words. And it lets it transforms the XML literals into some JavaScript code that is valid JavaScript code for every environment. And typically that is going to be an invocation of the react.createElement method. So let's see what JSX looks like. Here we see a piece of JavaScript where we have an XML literal. Please be sure there's no string quotes around this. This is just a piece of XML. And of course, I can add some text in there. And as we would basically expect, the output appears here below. The second line of the snippet is how you bootstrap a React application. You pass it an element, so that's a JSX element, and you pass it a place in the document object model where the application needs to be mounted. And as soon as you have done that, the application will run. And as soon as something changes in this element, the text changes, or maybe a nested element appears, React will re-render the application automatically for you. That's the one-way data binding that I mentioned before. Now, these elements are valid XML. So this means they can have attributes. The attributes may have different names than you are used to from an HTML background. Most famous for that is the class name attribute. If you write regular HTML, you would say the div element has a class, but in React, or actually in JSX, it's called class name, because class, as we already saw, is a reserved word in JavaScript. It has a meaning already. It would be very confusing if we would reuse that. And now if I add some text inside this div, you can see that the CSS class red text is applied and the text indeed appears in red. But some of those attributes behave differently than you're used to. The style, for instance, can be a string, just like the class name that we saw before, but in this case we see it is an object. So we say the div has a style attribute, and the value of that attribute is actually a variable. That variable is declared here in line 1. It's style, and it's a JavaScript object with color red and font weight blue. Notice that here as well, font weight is capitalized differently than you might expect. If I apply it, it works again as expected. So what I'm basically saying here is that the div has an inline style applied, and the style is composed using this JavaScript object. Could also have been a string, as I mentioned, but this lets you build it dynamically, which can be very useful. So given that JSX is in fact XML, other rules of XML also apply. For instance, the rule that any XML document must have a single root node. In this example, we see a root, we see an element that is actually not an element. It's two elements with nothing in between. And as the output window already shows, React does not support this. It actually gives you a very clear message, if you ask me. It clearly states what is wrong. You have adjacent JSX elements, but they do not have an enclosing tag. Maybe you want a JSX fragment. Well, let's try a JSX fragment. Sounds cool. I'm going to add that. And now it works as we would expect. The JSX element is, the fragment is in fact a shorthand notation for this. So you could say it's an XML tag called react.fragment, but because they thought you're going to use this a lot, let's make a shorthand notation as well. The only disadvantage of this notation is that technically it's not valid XML anymore, because in XML, every element must have a name. These elements don't have a name. Alternatively, you could wrap the elements in an array. Then you need to place a comma in between, of course, and then it also works as expected. React will, in fact, introduce a fragment around it, but you don't see it here in the code. So now that we have seen elements, we can start thinking about components. Components are the basic building blocks of any React application. And the idea of a component is that it's basically a function that takes in some properties. You could say that are the arguments of the function, and it returns an element. By convention, components always start with a capital letter, an uppercase letter. Elements that are present in the underlying implementation, in our case, it's the document object model, are lowercase. So div is a lowercase d. But greeter, being a component, is not something that the browser knows natively. And that's why we started with a capital G. And then here we create an element from the greeter component that actually gets rendered. And as you can see, the component is returning an element. It's the same div that we saw before, and that's why we see that there in the output. So now that we've seen the basics of JSX, we can dive a little bit deeper into advanced use cases of JSX. The first thing that I want to show you is how expressions can be applied in JSX. Here we have a component which is called example, and it's a div element with a little bit of text in it, the answer to the ultimate question, blah, blah, blah. And the interesting part is there are the curly braces between the strong tag. Here I can start typing whatever I want as long as it's a valid JavaScript expression. So I can just enter the number 42, or I could enter the string 42. But given that it's JavaScript, I can also refer to variables I already have at hand, like answer to question of life. Or I could actually invoke a function, ask the question of life. And given that the function returns the answer to the question of life, you would expect that, right? From ask, that you get an answer. You'll get that output as well. So inside those curly braces, you can basically do whatever is valid JavaScript. The only rule is that rendering a component should be very compute efficient. So you're not allowed to do heavy computations inside this rendering. You're not allowed to perform any side effects, but we will see later how you can address that. Another thing that components can do is refer to the props or the arguments that they have received. So in this case, I have my greeter, I'm going to render it, and I'm passing it an argument or an attribute in XML speak with the value Romania. And here inside the element, I have the curly braces already there. I can start typing and I can say props dot name. And this name obviously corresponds with the name attribute I'm passing there, allowing me to inject a parameter into that component and then render it. Now this is looking pretty cool already. You can make it even a bit shorter using object decomposition. By decomposing the object, so not saying props, but saying, well, I get an argument and I want you to immediately decompose it into a local variable called name, I can skip the prop dot and immediately start typing name here. And it obviously gets the same result. Well, that's all nice and good. Another thing that we can do in JSX is that we can include control statements. The most simple one is a conditional. So here I'm creating a component that does something based on whether I am happy or not. I'm decomposing the props into a local variable happy. Here I pass the value true. Notice that it's between curly braces. So this value of true is actually a Boolean value, and it is not a string literal with that same name. Then the implementation of my arrow function is if happy, then return clap hands, else return dry tears. And I hope you're not surprised to see here clapping hands. And if I would turn from happy to sad by saying happy is false, then the conditional gets evaluated again. As I said, I'm passing a new value here, so the component is re-rendered, and I'm seeing the text drying tears. Second type of control statement that is allowed here in JSX is iteration, or you can basically, it's kind of a for loop. First, I create an array of ticker symbols. In this case, it's two famous Dutch companies, Heineken, a beer brewery, and Philips, the electronics company. And let's say that I want to see the ticker names in a list. Well, then I have a component called ticker list, which I pass the array. Here in the top row, the top line, I have a component called ticker, which just outputs the text. I could change it a little bit, but that's not the most important thing here. And the ticker list is a component that takes the symbols. Again, I've decomposed the arguments, and then invokes map on it. So it's an array, and the map function on an array takes as an argument another function, invokes that function on every item in the array where you call it upon, and then returns a new array with the outcome of each invocation. So for Heya, I'm calling this function, which renders a ticker with a symbol passed as a parameter, and that eventually creates the ticker there. And then for Via, it's the same thing. So that's how you can iterate over lists, and that's something that you might quite often do. So now, if you're anything like me, at this point, you'll be wondering, how does that actually work? Because it's pretty cool. I mean, the UI gets updated, and these properties being injected and whatnot. But what's happening under the hood? We'll dive into that because it really helps to understand this a little bit if you are going to apply React in your next project. The magic happens in two steps, and the first step is during the build of the application. What we've done so far, we just wrote some components and combined them. But if you start a build, you will typically invoke Babel or the TypeScript compiler, which will convert this piece of XML into this piece of JavaScript. And as I said, this piece of XML is not understood by the JavaScript runtime, but this piece of JavaScript for sure is. You can recognize the name of the component, you can recognize the properties, and this null over here is just, we don't have any child elements. That's the first piece of magic. So what your browser runs is not this, your browser runs this. The second piece of the magic happens at runtime. At runtime, all those React.createElement invocations that we saw create kind of a tree of components, and React builds a virtual model of what your document object model should look like based on that tree of components. So each create element returns an object, those are nested, and that kind of forms a mental map of what the document object model should look like. And then React will start comparing that mental model of what the DOM should look like to the actual document object model. And wherever it sees a difference, it will execute operations on the actual DOM to make the actual DOM align with the virtual DOM. But the interesting part here is the fact that it only does the necessary things. So it is not going to rebuild the whole user interface every time something changes, only the things that changed compared to the previous render. Those changes are executed, and that's what makes React a very efficient library. This process is called reconciliation, syncing the virtual and the actual DOM, and it is based on two major assumptions. The first assumption is that if it sees an element of type A, and then the next render returns an element of type B, it assumes that the subtree will be completely different. And the second assumption is that if you re-render a component with child elements in an array or something, that those child elements must have a key property to identify those child elements. That one is actually necessary to tell React what makes two elements the same or different. Let's dive into this. So what we see here is an example to showcase the first assumption. I created an app component. I pass it a name and a language. And as I said before, as soon as I give a component different props, for instance, I change NL to EN, the component will be re-rendered. This method gets executed, and rather than the Dutch greeter, we are now seeing the English greeter. And same, of course, if I change it to Romanian. I hope I didn't make any mistakes in translating it there. Why does this work? Because we see a different child element. We now see a Romanian greeter rather than a Dutch greeter, and React will assume, based on that first assumption, it will conclude that this whole div is obsolete and that those characters inside that div are obsolete. And it will just throw it all away, throw it out of the window, and start building a new piece of document object model, this part. You could say that's not efficient. It might have been able to reuse the name part. But the thing is, if you would go that way, you would need to traverse the whole document object model until the very last leaf element before you are sure that you've seen everything. And this is kind of an optimization where it says, well, at some point you got to make a choice and decide, I'm not diving into it, I'm just throwing it away and recreating it. The second one is a bit harder to understand, the key prop. This one is especially relevant for iterating. We earlier saw the tickers, and it basically looked like this. I have now added a few more symbols, and it should have shown at this point. Yes, like so. As you can see here, it shows prices for those tickers. It's a random price, it's just calculated. And as soon as I start shuffling the items, I didn't show you how that shuffle component is implemented because it's not relevant at this point. Let's remember that Heineken is 797. If I shuffle it, Heineken is now 649. What does this mean? This random price method got executed again. But why is that? Because it's Heineken still, after all. It should not recompute that price, should it? Well, it did, because at the second render, React could not say that the Heineken that now appears here at the third place is the same element as previously was there, the first element. So it considers the old one obsolete, drops it, then recreates the new one and starts computing the price again. And you can fix that using the key prop. The key prop is something that you don't consume yourself, you just pass it on. And now if I give it the symbol as a key, and I start shuffling again, Heineken is now 213. Heineken is still 213. Heineken is still 213, even if it's shuffled places. So how is that possible? Because the key prop tells React the Heineken that you in the first render saw as the initial element of the array and the Heineken that is now the second element of the array are actually the same Heinekens. So you don't need to remove the element and recreate it. You can just move it around rather than recreate that, than removing it and recreating it. This key must comply with two rules. It must be unique. So two elements in the array cannot have the same key, obviously, because then it wouldn't be identifying anymore. And it also needs to be stable. So if you shuffle the array, as we do in this example, then the key for an element must be the same no matter how often you shuffle. So you can't use the index, for instance, because if you shuffle the array, then the index changes. Typically, you will have some kind of a back-end identification for a record, which may be useful, or in this case, we have the ticker symbol, which is also useful. So it must be stable and must be unique. That's the two main rules for the key prop. Now, we've seen pretty much what React can do already, but we haven't done anything useful yet. If we want to make a useful web application, we need to interact with our environment. And I'm going to show you a bit about how you can maintain state, how you can react to user events, how you can fetch data, and how you can store data. The most simple thing is keeping a little bit of state inside a component. You could say it's a kind of a of a memory of a component. In this case, I'm using a counter, which is not very useful because it uses a piece of memory. It says that the value is 0, but you can't change it yet. By the way, here we see array decomposition in practice. So we decomposed the result of this use state, which is an array, into two elements, the actual current value and a function which lets you update the value. But to update it, we must be able to react to an event. How do we do that? Well, event handling in React looks pretty much the same as event handling in plain vanilla HTML. But event names are a bit different, especially the capitalization is different. An event handler is always a function. It can never be a string, which it can be in plain HTML. An event handler is always bound to the component that owns it, and it can never live globally, which also makes it easy to clean them up, because if the component gets cleaned up, the event handler is automatically removed as well. And the event handler can receive an event parameter, but that's actually a synthetic one. It's not the raw browser event, but it's a little thin wrapper around it, so it becomes browser agnostic, and your application doesn't need to check if it's running. Your web app doesn't need to check if it's running inside Chrome or Firefox or any other browser. So let's see how we can leverage that. Here we see the same counter component, but now I'm declaring two additional functions which help me mutate the state. I've got an increase function and a decrease function. And increasing it is just setting the counter to a value +1. Decreasing is a matter of setting the counter -1. And here I have buttons where the onClick handler is bound to those helper functions. Let's see if it works. It works brilliantly. And I could actually play the whole afternoon with this, but that's maybe not a good idea because we've got more to cover. But as soon as I click the button, the helper function gets invoked, which in turn invokes the setCounter function with the new value for that counter. Same pattern applies for onChange callbacks, for instance. So here I have an input of type text, and I can start typing a few letters there. As soon as I do that, the onChange event fires, the update name method gets invoked. Helper function that actually stores the name by reading it from the document object model element that fired the event. And here we have an onClick that we can use to do something with that value. For instance, we could say, just show me an alert with the name. Right? And there it is, a pop-up saying, hey, Romania. So the next thing I want to cover is how you can fetch data over HTTP. As I said, React doesn't provide anything out of the box, so we are going to write some plain old JavaScript code to do that for us. And that code will use the fetch API, which is present in all modern browsers nowadays. So let's build up that piece of code line by line. What I eventually want to have is a method that gives me a random joke. Here I have a serverless function, which runs in an Oracle Cloud thing that returns me a random joke. And fetch is the browser function that can actually invoke that API. It gives you a promise. So the first thing that we need to do is check if the status of that promise is actually in the OK range. And if so, we resolve the promise, else we reject it. After that, we parse the response body, assuming it will be JSON, and then eventually we extract the joke property from that. And if we have that, we can declare a component, write a component that actually uses it. That component, as long as the call is running, will display the text loading. Otherwise, it will display the text of the joke, and the joke is part of the state of that component. So here, the fetch random joke function is an async helper function that will await the promise of the get joke that we saw previously. And once that's done, we can say set state. We can say, well, here's your joke. Jokes are on me, and loading is false. And as soon as we do that, we see that the API is invoked, and we can actually enjoy a good laugh. Whoa, what's this? Excuse me, I don't know what went wrong there, because all of a sudden I went to a different tab. We saw that. All right. Storing data. So what we saw is how you can store data inside your component. What if you want to persist it? You have two options. You have local storage and you have session storage. Local storage and session storage are both part of the web storage API, which is again present in all modern browsers. And it allows you to do key value storage. That means that if you want to store any value that's not a string, you need to stringify it using JSON and parse it using JSON. If you want the storage to be persistent during the browser session, you go for session storage. Otherwise, you would go for local storage, which will even survive a browser shutdown. Now, we've seen basically everything we need to know to deliver an app. If you want to debug the application that you're building, I highly recommend to install the React developer tools, which makes your life a lot easier. It will allow you to inspect the React tree of components rather than only the generated document object model. It will also give you source maps so that your debugger shows you the code that you wrote rather than the transpiled code. That's not easy to debug. You, of course, want to test your components, and you can use just for that with the React testing library. It allows you to check whether your component does what you want it to do. So for instance, if you have your greeter component, you can pass it a parameter, render it, and then inspect that somewhere in the screen you see this particular text. And by passing /I here for the regex, it's case insensitive, by the way. You can even test how events are handled. So in this case, I have a button, and I want to be sure that if the button gets clicked, my component will invoke the callback. I pass it a mocked function, I fire an event on it, and then I expect my function to be called. I don't know what's going wrong there. It's somehow navigating to a different page. I'm sorry for that. So if your application is done and dusted, you're ready to ship it to production. To do that, I highly recommend to use Create React App. It bundles a bunch of tools and makes sure that they all work together. I've tried doing this myself, and it's just not the fun part of your job to wire those all together. TLDR, please use it because it helps you, and it combines a lot of best practices that have been established in the greater React community. The main things that you need to remember is how to install it. With npm, you can install the Create React App package, and then you can run Create React App. It will scaffold out the whole application for you. Using start, you can start developing with hot reload and whatnot. Using build, you can get an optimized production build, tree shaken, so all code that is not necessary will be removed. And using npm run test, you can run the unit tests that we saw before. It's time to wrap it up. If you want to start working with React, please again use Create React App to save you a lot of setup time. Start thinking about your application in terms of components, and preferably small components, because smaller means easier to test, easier to understand, easier to troubleshoot. And start thinking declaratively. What we saw today is that you can declare what you want your interface to look like and not focus on how to achieve that. Below you will find a few useful links to Create React App, to the API that generates really bad jokes. And if you are more curious about security in React, I highly recommend checking out the content that Philippe de Rijk created about building secure React applications. Thank you so much for your attention. I'm going to move to the chat and see if there are any questions from your side.
Hello, thank you. I think there is one. If you can see it and read it, or if not, I can tell it to you.
Yeah, I can see it. It's a question about
Okay.
web crawlers.
Yeah.
That's an interesting one, actually. As you may have understood from what I told you, a React application gets built dynamically by the browser. So from a web crawler perspective, it's an indexed HTML with almost nothing except an empty div and a bunch of JavaScript that will get loaded. I don't think that many web crawlers will be powerful enough to actually run the application and see what's happening. So in the approach that I shared with you today, a web crawler will not be able to make a lot of sense out of that web app. You can give it a few hints by passing HTML meta tags, but that would probably be all. There is an effort to work on server rendered React apps, so the same patterns as that we saw today, but then rendered server side. That means if a web crawler would request that web app, it would actually get at least partially built up document object model already. In such a case, it will probably be easier for the web crawler to understand what the application is about. Does that answer your question?
Yeah. Thank you. I think that's all. So yeah. Thanks. Yeah. So he said it's
Yeah,
okay.
apparently so.
Yeah. Okay. Thank you.
All right. Thank you for having me today. Enjoy the remainder of the Vox days.
Thank you. Have a good day.
Likewise.